In this video, we're going to look at another example of volumes by slicing. The base of solid is an elliptical region in the xy plane with an elliptical boundary curve 4x squared plus y squared equals 4. Cross sections perpendicular to the x-axis are isosceles right triangles with hypotenuse in the base. The question here is to find the volume of the solid. Let's draw a picture of the cross-sectional slice and also the base of the solid. The base of the solid is an elliptical region, so we're going to find the x and y intercepts of this ellipse so we can plot it. 4x squared plus y squared equals 4. This is the equation of the elliptical base. Let's plug x equals 0 and solve for y. That gives us the y-intercept. X is 0. We get y squared is equal to 4. Square root both sides and we get y is equal to plus or minus 2. Y-intercepts. Now let's plug in y equals 0 and solve for the x-intercepts. Y equals 0, we get 4x squared is equal to 4. Divide by 4 both sides and we get x squared equals 1. Square root both sides and we get x is equal to plus or minus 1. So x is 1, y is 0, x is negative 1, y equals 0. These are of course the x-intercepts, and the y-intercepts is going to be 0, 2, 0, 2, and 0, negative 2. These are the y-intercepts of the elliptical boundary region. So now you can see that we have sketched the ellipse 4x squared plus y squared equals 4 using the x and y intercepts. The cross-sectional slice is a isosceles triangle. The base is the hypotenuse. The hypotenuse is in the base. And so that's going to be AB. AB is the hypotenuse of the cross-sectional slice. Hypotenuse. All right, so here we have the cross-sectional slice, and you can see how angle C is 90 degrees. Why is that? It's because it's opposite the hypotenuse. The hypotenuse is AB, so this is 90 degrees. The height bisects the angle. That makes it 45 degrees. So we have, this is 45 degrees. So for that reason, this length here is y. This length is also y because of the usual 1, 1, root 2 triangle. 1, 1, root 2. So if this is y, this is also y, and this will be y root 2. All right, and that's because we have the 45, 45 triangle. 45 degrees, of course, is pi over 4 radians. All right, so the height of a triangle is also y, so we can find the cross-sectional slice area as a function of y will be 1/2 the base, 1/2 of the length AB, times the height of a triangle. So we get 1/2 of 2y times the height of a triangle, which is also y. All right, we're going to look at that in more depth. So we want to find a formula for the cross-sectional area as a function of x so we can add these cross-sectional slices in the x direction and find the volume of the solid. All right. So what we have is a triangle ABC is an isosceles triangle with hypotenuse in the base. And because it's isosceles, the length BC is equal to AC. But because it's an isosceles triangle, the opposite angles are also equal. So angle B equals angle A. Because you have an isosceles triangle, the angles opposite equal sides are also equal. Now, we also know that angles, total angles in a triangle add up to 180 degrees. So angle A plus angle B plus angle C is equal to 180 degrees. But angle B is equal to angle A. So we get 2 angle B plus angle C is equal to 180. And if we solve for angle C, we'll get, angle C is actually 90 degrees. We know that. So if we solve for angle B, we get 2 angle B plus 90 degrees is equal to 180. And subtract 90 both sides, 2 angle B is equal to 90 degrees. So angle B is 45 degrees, which is pi over 4 radians. Now the height of the triangle bisects angle C. That means this angle here is going to be pi over 4. And also this angle is pi over 4. And for this reason, the slice area is going to be 1/2 the base times the height So this is equal to 1/2 the base. The base has a length 2y. What is the length of the height? Well, if this is y, this is also going to be y because we have the 1, 1, root 2 triangle. 1, 1, root 2. There's the 45, 45, pi over 4 radians, pi over 4 radians, times the height, which is y. 2 cancels with 2. We get a cross-sectional slice is going to be slice area. Slice area is equal to 1/2 of the base, which is 2y, times the height, which is y. This is the height here. And 2 cancels with 2. We get y squared. This is a cross-sectional slice area. All right, so the slice area is equal to y squared. But we need the slice area to be a function of x, not y, because we're adding these slices in the x direction. We're integrating with respect to x. So we're going to apply the elliptical boundary condition, 4x squared plus y squared equals 4, to solve for y in terms of x. So isolating for y squared is equal to 4 minus 4x squared. So the cross-sectional slice, a of x, is equal to y squared, and we solve for y squared in terms of x squared using the equation of the ellipse. Y squared is equal to 4 minus 4x squared. This is the cross-sectional slice, a of x, is equal to 4 minus 4x squared. Now, the key concept is that the area slices, these cross-sectional slices, are perpendicular to the x-axis. So we need to find the cross-sectional area slice a of x, which we have found, and add up these vertical isosceles cross-sectional slices in the direction of the x-axis to obtain the volume. When we say add up, we really mean to integrate in the direction of the x-axis. So we have a of x is equal to 4 minus 4x squared. X is between 1 and -1. So if you go back to this diagram, we're adding up these cross-sectional slices. Let me see if I can draw one of these slices here. It's kind of like that. And we're adding up all these slices. And there's more slices here, infinite number of slices. We're adding them up in the x direction and to find the volume of the solid. All right. So now let's integrate the area slice a of x to find the volume. Volume is integral a to b, a of x dx, where a is equal to -1, b is equal to 1, and the cross-sectional slice was found to be 4 minus 4x squared. So the volume is the integral from -1 to 1, 4 minus 4x squared dx, integrating with respect to x. But because the integrand is an even function over a symmetric interval, we can apply even symmetry, and this is just going to be 2 times the integral from 0 to 1, 4 minus 4x squared, integrated with respect to x. So volume is equal to 2 times, what is the antiderivative of 4? That's 4x, reversing the power rule. What is the antiderivative of 4x squared? That's going to be 4, x cubed, add 1 to the exponent, divide by the same. Evaluate it from 0 to 1. Now apply fundamental theorem of calculus, put the upper limit in minus the lower limit. So 2 times, putting the upper limit of 1 in, we get 4 minus 4/3. Minus, put the lower limit in, we get 0 minus 0. So the volume is equal to 2 times 4 minus 4/3. Taking common denominator, we get common denominator of 3. So 1 goes into 3. 3 times 4 is 12, minus 3 goes into 3. 1 times 12 minus 4, adding these fractions, we get 2 times 8, that's 16 over 3. That's the volume of the solid. So the volume of solid is equal to 16 over 3. There it is. All right, thanks.